Hello, I welcome you to this lecture, Laplace Transform. So in this, we'll continue with differential equations. How to solve a differential equation using Laplace Transform. Laplace Transform is an important method to solve linear ordinary differential equation. So it is very useful in solving differential equations because when you take Laplace transform of a differential equation, it gets changed. It changes. When you take Laplace transform of a differential equation, it changes into a simple algebraic form. The differential equation is changed into a simple algebraic form, which becomes easier to solve. So that is the advantage. So Laplace transform finds important use in solving differential equation in mathematics and also in very much in process control. So already in our previous lectures, we have seen solving a few differential equations using Laplace transform. For those who have seen those lectures, so this lecture will be a summary of that procedure in which we solve differential equation using Laplace transform. Those who are not listen to those video lectures, we will get to know the general procedure of solving a differential equation using Laplace transform. It's a simple procedure, and after knowing this, you can go back to those lectures. Those lectures links I am giving those links at the end of this lecture. At the end of this video, you will have the links for the previous lectures in which we have solved differential equations. So let us go into this procedure. So those who are not seen those lectures, this will be a general procedure. Those who already seen those lectures, so you can refresh yourself again, and this will be a summary of that procedure. Okay. So let's get into the procedure of solving the differential equation. First step is take Laplace transform of the equation on both sides. So what is the Laplace transform of a derivative? So if you have a nth derivative, what is the Laplace transform? We have seen already the table of transform in the first lecture on Laplace transform. The Laplace transform of an nth derivative is this: s power n f of s minus s power n minus 1 f0 and so on. Now similarly, this is the nth derivative, can be used for first derivative, second, third, fourth. So I've given here for third derivative, Laplace transform of third derivative. This is Laplace transform of second derivative and Laplace transform of first derivative. Normally in process control, you will get maximum up to a differential equation with the highest order of third derivative. So take the Laplace transform of the equation on both sides using these equations. Then second step, substitute the initial values. The initial values will be given like f0, f dash 0, f double dash 0, all these will be given. So substitute them into these equations. After taking Laplace transform, substitute the initial values. Then simplify the equation and solve for f of s. Simplify and solve for f of s. When you get f of s, that f of s will be the Laplace transform of the required function f of t. And the simplified f of s you get will be the Laplace transform of the required function f of t. That's what, when you take Laplace transform of the differential equation, you get a simple algebraic equation in the form of f of s. The next step, invert this f of s. Invert f of s to get ft. So inverse Laplace of transform of f of s. So how do you do this? So actually this step is the first step. First and second and third steps are very easy. This fourth step is little tedious and maybe lengthy. depending on the type of function you get. So if you get a simple function f of s, you may be able to invert it using any direct formula. Quite often, the application of direct formula may not be possible. So in that case, you have to split f of s into partial fraction, and you have to resort to taking inverse after splitting this f of s into partial fraction. So once you take inverse after splitting into partial fraction or by any method, you get f of t. This f of t is the final required solution of the differential equation, which will satisfy the given initial differential equation and the given initial conditions. So the final f of t you get after taking inverse of the f of s will be the required solution of the differential equation satisfying the given initial conditions. So this is a general procedure of solving a differential equation using Laplace transform. I hope it is understood. We'll see you soon with more lectures on Laplace transform.